Everyone, welcome back. In this video, we're covering the 1998 FRQ question number 3. This question has to do with velocity time graphs and also how acceleration plays into these. So take a second to pause this video if needed and read through the question and then meet me back here for the problem solve. Okay, so let's take a quick second to analyze this graph together. You always want to pay attention, of course, to your y-axis, which in this case is velocity in feet per second, and also our x-axis, which is time in seconds. And then our table is basically displaying the same exact data, just obviously in table form rather than graph form. One thing you also want to pay attention to always when you're doing these questions is just the rough slope of this line. So I'm noticing I have this positive slope here, it goes to 0 here, it goes negative, hits 0 again, and then goes back up. So normally I don't take too long to do that, but I kind of just make a mental note of what my slope is and where along my graph. Okay, so let's jump into 3A. So this question says, during what intervals of time is the acceleration of the car positive? Give a reason for your answer. Answering this type of question is exactly why I like to keep my slope in mind when I'm looking at the graph. So the acceleration is the derivative of the velocity. Another way of saying that is that the slope of the velocity gives the acceleration. So when they are asking when the acceleration is positive, so they're saying when is a of t greater than 0, right? This is the same as asking when is v prime of t greater than 0, right? Or when is the slope of v of t positive, right? So let's go ahead and look back at our graph. If we did this when we looked at our graph, we already have a pretty good idea, right? So really all up here, we have this positive slope until we hit 35 seconds where it becomes 0. Then it turns negative down here to 45 seconds, and then it goes positive again. So what we would say is we would say that the acceleration is positive for 0 to 35 seconds and 45 to 50 seconds because, I'm going to write that up here just because I ran out of space. So because v of t, or the velocity, is increasing on those intervals. So on the interval 0 to 35 and, sorry about my poor handwriting there, and 45 to 50. All right, great. Let's move on to part B. Okay, so part B asks us to find the average acceleration of the car in feet per second squared over the interval 0 is less than or equal to t is less than or equal to 50. So again, average acceleration, we're just thinking of slope, right? What's the formula to find the average rate of change or the average slope? It's just y2 minus y1 over x2 minus x1, right? Our simple algebra 1 formula. So this gives us our x values, right? So in our denominator, we are going to have 50 minus 0. And then in our numerator, we are going to have our output values. So here we have 0, and then at 50, it looks like it is about 72. Let me double check that. Yes, it would be 72. So let's go ahead and just plug that in. So it would be 72 minus 0 over 50 minus 0, which equals 72 over 50. And then we can just add in our units, feet per second squared. And again, this would represent the average acceleration of the car over the interval 0 to 50. Okay, moving on to to part C. This one says, find one approximation for the acceleration of the car in feet per second squared at t equals 40. Show the computations you use to arrive at your answer. Okay, so this says one approximation because you can pick different points surrounding 40 to get an approximate slope. So we are looking at this point here. So I'm going to choose these 2 points, but really there's multiple points that you can choose. I like to just kind of evenly space into it that way. So I'm going to pick this point, 35, 81, and I'm going to pick this point, 45, 60. So again, in order to approximate the acceleration, we are going to use our slope formula. So we're going to do y2 minus y1 over x2 minus x1. And I'm going to do 60 minus 81 over 45 minus 35, which will give me negative 21 over 10. Now I just have to add my units, which are feet per second squared, and then I am done. I, of course, want to just kind of think about this. This answer is approximately -2, right? So just looking at this, I do want to just make sure that makes sense, and that does look like it's a slope of approximately -2. So that's just kind of me mentally double checking my work. All right, thanks so much for watching, and I'll see you in the next one.